So this is question 2C of the practice exam for level 3 probability concepts from term 3, 2017. In the emergency department of the hospital in this time period, 38% of patients were treated by the nurse staff and discharged. Of the remaining patients who stayed to be seen by a doctor, 2/3 were admitted to hospital. 5% of the patients who were treated by the nursing staff and discharged initially later returned and demanded to see the doctor. Of these, 25% were admitted to hospital. What is the probability that a patient who was admitted to hospital from the emergency department was initially treated by the nursing staff and discharged? Now, when you read a question like this, initially we all feel overwhelmed, and so that's normal. It doesn't mean that you're not smart enough to do the question. We just need to start by thinking which diagram is going to be the easiest way to represent this information. So if we go back to our flow diagram and think about it. Now, if you look at this diagram, the key thing is what I've circled here in red for this question. Anytime that some of the numbers provided in the question are conditional probabilities, that means out of a subgroup, a tree diagram is going to be the easiest way to go. Okay? And that's the case here, isn't it? Because if we go back to the question, quite a few of these numbers are actually conditional probabilities. For example, the 2/3 here is not 2/3 of all the patients, it's 2/3 out of the remaining patients who stay to be seen by a doctor. So it's only out of a subgroup, the remaining patients. Because there's numbers in this question that are out of subgroups, not out of the whole thing, we need to use a tree diagram. Okay? And that's always going to be the case. Anything's out of a subgroup, think tree diagram. So the first split in our tree diagram, the way to know which part goes first, it should always be the probability that is out of the total. So which of the figures here is actually out of the whole lot? Not out of a subgroup. And it's the 38%, isn't it? Because it says 38% of patients. So 38% of all the patients were treated by the nursing staff and discharged. So that's going to be the first split. Discharged initially or not. So initially just discharged was 38%, and we always write it as a decimal or as a fraction, never as a percentage when you're doing a tree diagram. So initially discharged or remain to be seen by a doctor. And so that must be, what's 1 minus 0.38? And it's 0.62, isn't it? So 2/3, so what it says, of the remaining patients who stay to be seen by a doctor, so that's down here, 2/3 were admitted to hospital. So 2/3. Okay, what happens to the rest of them? We're not told. So we would just say the other 1/3, not hospital. Okay, I'd like you to see if you can do it from here. So pause the video and write down what we've got so far and have a go at finishing this question off. And you'll get way more out of it than if you just watch this. Okay, what are we told next? 5% of the patients who were treated by the nursing staff and discharged. So initially discharged, 5% of those later returned and demanded to be seen by a doctor. So 0.05. And so the other 95% must not have. Okay, and they didn't return. Okay, so of those 5% that returned to be seen by a doctor after being discharged initially, 25% went on to be admitted to hospital. So hospital is 25%, and then not hospital must be what? The other 75%. Okay, so we've got all the information down now, and now we read the question again. Always reread the goal of the question after you've got down the information. What is the probability that a patient who was admitted to hospital from the emergency department was initially treated by the nursing staff and discharged? So let's tick the branches involved. So admitted to hospital is here and here, isn't it? And so first thing we need to do is we need to work out the probability that a patient is admitted to hospital, ends up in hospital. So to do that, we're going to need to work out the probability of these two outcomes by multiplying along their branches, and then we're going to need to do what? We're going to need to add them. Okay, so let's work out the first one. So the probability they are initially discharged, but then end up in hospital. So we need to multiply 0.38 times 0.05, 0.25, which is that they end up in hospital as well. And we get, now this number here is standard form, this, the E means times 10 to the power of, and it means that what you do is you move the decimal point back that number of places, or forward I should say that number of places, so 3 places, 1, 2, 3. So it's used for very small numbers. And so that means 0.00475. Another way to think of it is the number at the end, which is a -3, that's how many zeros there will be at the start. So if you include the 0 before the point, that's 3 zeros, isn't it? So that's what that number is. So it's not likely, is it? If they're initially discharged, not likely they end up in hospital. Okay, those remaining to be seen to see a doctor. So 0.62 times 2/3. So we would go 2 fraction button 3, 2/3. Or you could go divide. And we get 0.413 recurring, which we can write as 31 out of 75. Now, see how I hit the fraction decimal button? See, if I leave that as a decimal, I'm going to have to round it, which is going to be annoying. So I can just hit the FD, which is the fraction decimal button, and get it more accurately as a fraction. So that's 31 over 75. Like that. Okay, and that's going to be more useful. Okay, so now the probability they end up in hospital, we just add those up. And we get 0.41808, and it's going to be a nasty decimal again, so I'm going to hit the fraction decimal button, and that's going to be more accurate, isn't it? So 5,017 out of 12,000. Okay. Now reading the question again. What's the probability that a patient who was admitted to hospital, so this is a conditional probability, conditional on them being admitted to hospital, was initially treated by the nursing staff and discharged? So we need to think about how we do a conditional probability calculation. If we go to our formula sheet and look at the formula for conditional probability, and it's down here. Okay, this is how we want to do it. So we're going to copy down that formula for a start. So the probability of A happening given that B happens equals the probability of A and B both happening divided by the probability of B. Okay, so let's think about what is the B in this one. The B is the condition. So that's those who are admitted to hospital. So I'm going to swap B with hospital. You do the same. Okay, now what's A? Okay, so A must be that they were initially discharged by the nursing staff. So I'm going to swap A with the words initially discharged. And so then the probability A and B becomes what? Becomes the probability of being initially discharged and hospital. So where is the event initially discharged and hospital? Where is that on our tree diagram? Well, where's initially discharged? That's here. So initially discharged and you end up in hospital must be this outcome here, mustn't it? So that's 0.00475. So that's going to be the numerator. It's going to go on top. And the denominator is the probability of ending up in hospital. So that's going to be this one here. Okay, and then whacking that into a calculator, we get 0.01136 to 4 significant figures. So what's that saying? And is that sensible? Well, it's saying that if you end up in hospital, there's only about a 1% chance that you were initially discharged. Does that make sense? Why does that make sense? Well, you would hope that of those who end up in hospital, most of them weren't initially discharged, right? Because that would be a bad thing. If you need to go to hospital and they send you home, that's a really bad thing. So you would hope that that error only gets made a small percentage of the time. So that's a sensible answer, isn't it? Always stop to check whether your answer is sensible. Part 2. A patient reports from this that the nursing staff get their treatment wrong 25% of the time. Discuss any assumptions and explain the mistake that this patient has made. Right, so what I'd like you to do is to pause the video and have a think about this. Read it carefully, look at the tree diagram. Only hit play once you've actually had a good think about it yourself. Have a go at writing the answer in your own words too. Don't be afraid of getting it wrong. Just have a go. Okay, so what's the key thing that you're uncomfortable with this claim about 25%? Where do you think they've got that from? Well, the only place we can see 25% in the diagram is here. And what's that 25% of? It's 25% only of those who return to see the doctor. Okay? Now, of those discharged, that actually excludes a whole lot, doesn't it? Because 95% of those who were initially discharged by the nurse didn't even return. So that 25% is only of the 5% who returned to see the doctor. Now, if we look at the other people that end up not in hospital after actually not being discharged, they've already been to see a doctor. So that's not the nurse's mistake, is it? It may be that the nurse kept them on because they needed to see a doctor, but it wasn't bad enough to go to hospital. So we don't need to worry about that bottom side of the tree diagram at all, because there's no evidence that that's a mistake the nurses have made. The only thing we need to focus on is the top part, those who were initially discharged by the nurse and still end up in hospital. And if you were initially discharged, what's the probability you actually end up in hospital? Well, we only need to look at this probability here and this probability here and multiply them. Because if we know you've been initially discharged, then the 0.38 is no longer relevant. Okay? So we just need to work out what's happened after that, after they've initially discharged. So I've got to go 0.05 times 0.25, and we get 0.0125. Okay, so that's more sensible, isn't it? That's saying that if you were initially discharged by the nurse, the probability you end up in hospital is actually only 1.25%. So let's write that down. So only 1.25% of patients initially discharged by the nurse still end up in hospital. Not 25%. And so explaining the mistake that the patient has made, they made the mistake of ignoring the fact that 95% of those initially discharged didn't even return to see the doctor. So the 25% is only out of the 5% who did. Okay, and so just checking the question again, have we done everything it asks? We've explained the mistake. We haven't really discussed the assumptions. We need to write that down too. So what assumptions are we still making here? What do you reckon? Well, we're assuming that the only mistake the nurse the nurses can make is in their treatment are the ones where they discharge them but they end up in hospital. There may be other mistakes as well, right? Like we don't know other treatments the nurse might recommend that end up being wrong. So we're not seeing all of the information here. So this only focuses on the mistakes that involve the nurse discharging a patient that ends up in hospital. So I've just said, however, this still assumes that the only error the nurse made was to discharge patients who later end up in hospital. And so there may be other mistakes that they could have made too. Okay, so it just always really pays to make sure that you've answered everything it says in the question. Alright, see you later.